All right, welcome back to Stat 2050 at the University of Wyoming, online, having a great time. Okay, so it's a new week. That means new stuff. Thankfully, though, we're not going to be doing any math. We're going to get the computer to do it all for us. And in fact, I'm going to get the computer to do it for you, so you don't have to do really any pen and paper kind of situations, right? So before we get into it, we got to talk about the album of the week. We're doing it a little bit different this time. Her name is May Earlywine. Super cool. She has a few albums out already, and they're pretty good. But there's two songs. There's a new album that's coming out, and she's got two singles from that album. One of them is Days Go By here, and the other one is Anyway. Oh Lord. They're like super good, very, very like warm sounding, very nice, very chill, right? So I bet that this album that's coming out, which I think is coming out next month, I'm pretty sure it's going to be, it sounds like it's going to be pretty good based on these two singles. So when it comes out, check it out. It might be a good time. Also, the Woody Goss Band, this guy on the very far right over here. Let's see if we can get it closer. No. Yeah, that guy on the very right is the keyboard player for Wolfpack, a band I've already showed you. So, it's all connected. It's all connected. Life is beautiful. Okay, so last week we were talking about differences between two groups, right? We can kind of draw it like this, right? And that's that, right? We did a t-test. We had three different types of t-tests, but in general, we had a t-test to tell us whether or not we had evidence to suggest that, the two groups are different based on, some kind of characteristic. Whether they are innately different or whether we did something to one of the groups and left the other one alone, right? Okay, now in real life, oftentimes it's more convenient to test more than two groups, right? It's cheaper sometimes, and a lot of the times we just care about the differences between a bunch of groups rather than just two, right? Well, that's okay, because we have this tool here called Anova, right? And it's part of this big family of general linear models, okay? Now, last week, I also said that we were going to be getting into regression. We're going to be tiptoeing our way into regression with this idea of Anova. First, one, because I think temporally it makes a little bit more sense going from two groups to more than two groups, right? And then also, you've got a test this week, and I do not want to bombard you with a whole new topic. I'd rather just kind of get you in the door with this. So, without further ado, let's get it. Okay, so statistics, right? We're making this idea of a general linear model, a GLM. And essentially, we're given data, and it's got a bunch of different groups, in this case, more than two, right, whatever it may be. And our general linear model will kind of divide the data into two different piles, okay? The first pile we'll call a model. And whatever this may be, right, this is very general, right? But essentially, we're just creating a model here. It's like a very fancy t-test, or a big grouping of t-tests, kind of, in the Anova world. But we're making this model in an attempt to figure out how the world works a little bit more, right? So you might have three different groups, and they all have some characteristic that makes them different, right? We can model that and put it in sort of the general sense of things, right? And we get a general idea of how all of those things are related and how they work together. However, we don't get everything, right? There's still some information that is there that we're not able to define, right, with this model. And we just call that error. Easy peasy, right? So the error is just sort of what's left over from this, right? So the model is only able to explain a little bit based on these different groups, different characteristics, but there's still a little bit left over, right? There's still some that we just do not know. And we partition that, we kind of put that in its own pile, and we call that error. All right, very cool. Okay, So with this idea of a general linear model here, the most common one, at least in sort of the world that we're working in, is Anova. Okay, and what Anova stands for is just analysis of variance, right? Now this is all just a bunch of fancy talk for saying that we're going to be comparing more than two groups, right? So if we were to kind of cross this out, right, that's a t-test. That's a t-test, right? Actually, let me do it like this. Okay, so ignoring that group 3, we could just do a t-test between group 1 and group 2, right? Calculate this area between the two, and that's a p-value, right? But the deal is, when we get more than two groups, well, the picture becomes a little bit more complicated, right? Because now we're comparing group 1 to group 2, group 1 to group 3, group 2 to group 3, right? And then you can kind of look at it backwards too, right? A little bit of redundancy if we go back like this, but effectively that's what we're doing, right? So we're making many comparisons rather than just sort of the one here. And that makes the math a little bit complicated. And because of that, you're not going to do it. I'm essentially going to do it for you. And by that I mean I'm going to program it and just give you the model output rather than making you do a bunch of math, because it's just not, it's not worth it in the end, especially with this. It gets a little complicated, but that's okay, right? So the general idea is that we're looking at a bunch of different groups, right? And we can even do one more, right? It might be like over here, something like that, right? And then big time, right? This gets really complicated, right? This can get really complicated to do by hand, so we're not. So anyway, just like in t-tests, we have a null and alternative hypothesis, and thankfully, this time it's very similar to what we were doing last time with the t-test, where in the t-test world, the null hypothesis is that there is no difference between the two groups. That the difference is essentially 0, right? And then the alternative is just that there is a difference, that the difference does not equal 0 between the two groups. And in this case, in the Anova world, same deal, except we are now looking at the means of all groups, right? So they're essentially what we're saying here, the null hypothesis is that all groups are equal. All groups are exactly the same, right? Or at least on a statistical significance kind of level, right? And then with the alternative hypothesis, same deal, except we're saying that all of the groups are not all equal. Okay. Now notice sort of what I'm saying here with what the frame of reference is. We're talking about we're talking about all groups, right? We're talking about every single group. We are looking at the big picture, right? We are looking at the big picture. We are not looking at each individual group yet. Okay. We are just looking at the big picture. Okay. So one thing to note here is that we're not saying in the alternative hypothesis, we are not saying that they are all unequal, okay? Because essentially what this is looking at, it's looking at the big picture, right? So if only one of these is unequal, right? Or if one of these is not the same as the others, then the Anova will say this, right? But if they all do sort of look the same, something like this, right? Something like this, right? This, then we would say, okay, cool, right? This is more or less going to be we're going to go with the null hypothesis. But then the moment that something shows up way out here, well, then more likely than not, we'll go with this, right? So looking at the big picture, looking at all groups, not looking at the individual thing yet. Okay, so null hypothesis, all groups are equal. Alternative hypothesis, all of the groups are not equal. Okay, all right. Here we go. A little bit of terminology, just a little tiny bit. So essentially what we're doing here in the Anova world is we are comparing, we'll say in this case, 3 groups, okay? And let's say that they're all divided by, look at that, kind of looks like a DNA thing. Cool. Okay, anyway, sorry. this is maybe, we'll call this group 1, group 2, group 3, and let's say that it's, gosh, I don't know, car brands, okay? So, and we're measuring gas mileage, for instance, right? Okay, so group 1, group 2, group 3 here, right? This might be, we'll say this is Toyota, I don't know, Chevy, and Fiat. Okay, I don't know. Okay. So we've got these three things, right? We've got these three groups, okay? And it's these three groups that are essentially telling us how the outcome is going to change, how gas mileage is going to change, right? So this, and this, right? All of these different categorical things, all these different categorical dividers, essentially, are telling us, right, how the outcome might change, how gas mileage might change, okay? So any qualitative predictor is typically referred to in the world of Anova as a factor, okay? It is a factor, okay? And it's just that's a weird sort of word, not necessarily the same in English, right? But we're just saying that these categorical predictors, these categorical variables here, the thing that is telling us, the thing that is dividing what we are measuring, right, is known as a factor. And within that, let me actually bring this back. And within that, each factor has a certain number of levels, okay? So in this case that I've given here, between the three different car brands, right, and the gas mileage, the number of factors is how many? Okay. Well, we only have one thing that we're measuring here. We only have one categorical variable, and it's car brands. So that means that there's only one factor. Okay. But within that, how many levels are there? Well, we have 1, 2, 3 different car brands within the categorical variable car brand. So we'll say that this has 3 levels. So it's a factor of 1, right? Or it is just one factor with 3 levels, right? And we see that hopefully fairly clearly there. And in this class, I'm just sort of doing some projection here. It will almost always be, actually I'll tell you, on the test, I just finished writing it. It's always going to be one factor, right? You always have one factor in Anova, in this type of Anova. It's the levels that will change, okay? Okay, cool. So I guess I'll just leave this. No biggie. Cool, okay. So what we're doing is a one-way Anova. We'll only ever be doing a one-way, so it's not even like totally necessary to have that there. That means that we have one not qualitative. We have one quantitative outcome with one factor or categorical variable / predictor, right? Okay, cool. So in the last example, right, this whole thing here was the car brand, right? And we were measuring gas mileage, right? We were just dividing it into these different groups here. Okay, so the best way, I think, to kind of show you how this is going to show up on the test and how it shows up in real life too is with an example, right, per usual. So with that, I'm going to pause the video now, and then we'll get back into it here in just a second. So see you there in a bit.